Okay, in this video we will learn about an application of calculus, specifically chapter 3 in real world. It's called optimization. Okay, let me start with telling you what is optimization, what is an optimization problem. Well, if you wanted to find optimum value of some quantity, means you wanted to find maximum value or minimum value of that quantity. That's called an optimization problem. A problem which deals with finding optimum. Optimum means, well, the best, either max or mean value of quantity. And when it comes to the optimization problem, specifically from section 3.4, we will deal with word problems. So you have to set up everything yourself. First find the function and then optimize it. Examples would be, for example, find max volume of a box, well, with a certain surface area. So you have material to make a box, but there's a limit to your material, so you want to make the best out of it, the maximum volume. Or one may look for find shortest distance of two different, a point from a graph, a point from something in the plane. And another thing would be, for example, find maximum area of a rectangular enclosure with a certain length of fencing material. So if you have a certain length of material for making fencing, what would be the best you can get out of it? So it means that what would be the best area, maximum area you can enclose by these materials. Okay, how to solve it? So how to start solving optimization problems. So this is so basically you have been given a word problem, and now the question asks you find optimum value, maximum length, minimum distance. Where to start with? We have discussed these steps before when we were studying the related rate of changes. But what is important is that dealing with such problem, in general, word problems have two main steps. One would be modeling. By modeling, I mean put it in mathematical formulation. That's the first thing you have to do. First, you have to model, then deal with the function you have found. Okay, how about this thing? So this thing has several steps, but first to do is definitely you need to identify the quantities you're working with. So identify the quantities under investigation. So, well, what are these things? The length, the length or width of the rectangle area you want to make, whatever. And important thing is assign and choose variables. For each one, you choose a variable. Well, put width x, the length y, the area a. That's the first step. You have to start identifying what kind of animals you're working with. The second thing is that find the relation between the quantities. Then find the relation between the quantities. In other words, well, for example, the length and width, you know that if you multiply them, you get the area. Or if you add them and multiply by 2, you get circumference. So that's what you have to write down. So write, in other words, in terms of the variables, write down all the equations among the or equation involving all your variables. Involving your variables. Well, you may find more than one, two equations, but at the end, what is important, you have to combine these relations and make one big equation, or one equation that you will study. So find the main equation. What would be the main equation? The main equation would be something like this. You have a quantity to be optimized, and that is written in terms of an expression in only one of the variables. For example, you write as the area A in terms of only function expression in length, an expression in length. So if you have given that the length of fencing material is fixed, that will give you a relation between the width and length, and you can write area only in terms of length. So this would be basically a function of x, a function of an independent variable. And this is basically what you have now. Before we move to really what we need to do is then find possible values, find the domain for the independent variable. For example, see, the length can be only positive numbers. Yes. So you find all those conditions. Then if you do all these steps, your modeling is done. Now you have a function with a domain, and then you can go ahead and find maximum or minimum of that function. Then the next step would be completely mathematical and would be find the absolute extrema of the function on the given domain. For example, if the domain is closed, remember you need to find the value of the function at endpoints and critical points and see which one is the biggest one, which one is the lowest one. If the interval is not closed, you have to find the critical points and where it is increasing, decreasing, and then check the general form of the form of the function and conclude that what would be the absolute max or absolute mean of the function. So in next videos, you'll see me doing more examples and finding more of these optimizations, solving more optimization problems.